All right, welcome back, friends. This is section 8.3 titled Trigonometry. And so you do see we have some trigonometric elements in the world of geometry, even though this is something that you're going to expand a lot further on when you're in a couple of years from now when you take trig. We do get to touch on the foundational things and the trigonometric ratios. And essentially what's happening here, gang, let me just give you a little scenario. So you guys, so far, you're able to tackle something like this using the Pythagorean theorem. And then we got a little fancy last section, and we said, oh, okay, you got that down. Well, what if it looks like this? Can you solve that? And yes, if that was x and y, you learned that you have some shortcuts to be able to solve those missing sides. Well, what we're talking about today is, what if we get into a scenario like this? And it's a right triangle again, but now what if that's a 24? Oh no. How would we solve for x and y in this case? All right, or if it's a 25 or a 26. All the other combinations of the acute angles that aren't 30-60 or 45-45. We have to have something that we can do to solve these things, and that's what we're talking about today. So the trigonometric ratios that are standard across the board in mathematics, trigonometry, calculus, and now actually they're on the SAT also. So this is, like I said, we're scratching the surface here. So let's see where they're coming from, what we're talking about. What's a ratio? Well, of course we know that a ratio is when we compare things. We're comparing two numbers, two sides, something. Well, the trig ratios, they are comparing sides of a right triangle. So for instance, the first one, which we refer to as sine, and hopefully your trig teacher will show you where these words, how they originated, where they come from, things like that. We're just using them basically in a geometry class. So the sine of an angle refers to the opposite side for the angle compared to the hypotenuse. So we're comparing those two things. So for instance, angle A, if I'm referring to angle A, then the opposite side of A is right there. And of course, the hypotenuse is always the side across from the right angle. So when you want to compare the opposite side to the hypotenuse of an angle in a right triangle, we refer to the sine of the angle. So these are ratios or just comparisons. All right? The cosine will refer to the ratio that exists between the adjacent side to an angle and the hypotenuse. So for A, the adjacent is B. And of course the hypotenuse is still C. So when you want to compare the adjacent leg to the hypotenuse, we refer to the cosine. And the tangent will refer to the other possible combination that you could have, the opposite compared to the adjacent. So for angle A, the opposite is A, and again the adjacent is B, so we compare A to B. So don't think of these words as foreign words that are like, where are they coming up with these things? You needed some way to name the three different types of comparisons you can make for any given angle. You can compare the opposite to the adjacent to the hypotenuse, the opposite to the hypotenuse. And then when you guys take trig, you'll learn the inverse of all these as well, if you want to compare hypotenuse to opposite, etc. All right? So to memorize what we just talked about, I introduce you to something that'll stick with you the rest of your mathematical lives. And it's SohCahToa, right there. SohCahToa. Now, what is that acronym all about? Well, as you can see, so, the S is capitalized. That refers to the sine of the angle. O stands for opposite. And H stands for hypotenuse. So up here, we talked about the sine being opposite over hypotenuse, and that's what the so is all about, to remind you what goes with what. The ka in SohCahToa is the cosine. And the cosine refers to the adjacent. I'm just going to abbreviate it here, over the hypotenuse. And the toa is the tangent, being referred to as the ratio of the opposite to the adjacent. So this is no great mystery. This is just an acronym to help you memorize the ratios that correspond to which sides of a triangle that you're dealing with. Craziness, isn't it? SohCahToa. All right. Let's move along. All right. First problem is not even solving for anything, just recognizing what's happening. So check this out. What are the sine, cosine, tangent ratios for this angle T? So now you can see what's up. Angle T is right here. So the opposite side to T is 8, and the hypotenuse is 17. So there you go. The sine of T is 8/17, the ratio of opposite to hypotenuse. Right? The cosine is the adjacent, 15/17. And then, of course, the tangent is just 8 to 15, the opposite to the adjacent. So now the got it. Let's take a look at this. And for this got it, let's clear this up and start over. Now we're working with respect to G. So what's up, G? Right there. Sine of G. So the sine of G equals, so here's G. So what's sine again? Sine's opposite. So you say the word SohCahToa. So the sine is opposite, 15. And the hypotenuse is 17. So 15/17. And we'll learn later there's only one angle that could be that has a sine ratio of 15 to 17. The cosine, abbreviated cos. And that is my adjacent. So what is adjacent to G is 8. Hypotenuse again, 17. So sometimes people get confused as far as what's the adjacent, because the 17 could be adjacent, but the 17 is always the hypotenuse. So take your hypotenuse out of the equation when you're trying to figure out what's adjacent to a certain angle. So I'm looking at G. Well, adjacent can't be the 17 because it's the hypotenuse, so it has to be the 8. Right? And then the tangent of G, tan, how it's abbreviated, is the opposite. So toa, opposite 15, and adjacent 8. So if I'm using my acronym, opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. So there's your SohCahToa. All right, so that's just the first problem, is just setting up the actual ratios. Now let's see let's get into the good stuff. All right, so again, I deviate from the book a little bit. There's book examples you can always refer to, but let's check out what's happening here. Find missing side scenarios. So in this case, we just have x in 3 different locations, and the calculator is going to be necessary for this. So those buttons on your calculator that say sin, cos, tan, if you ever wondered what they meant, wonder no more. This is it. This is when we're going to use them. Back in my day, we didn't have fancy calculators. We had to look things up. Actually, that's not true. I had scientific calculators back in my day, but my teachers used to say it all the time. It used to drive me crazy. All right, well, here we go. So, first scenario, you can see, as I'm looking at this one, call it number 1. I can't use Pythagoras. I only know one side of the triangle. I can't use the special right triangle because that's a 24. Oh no, what am I going to do? Well, SohCahToa will save me in this case. SohCahToa to the rescue. All right, so you refer to the angle that you're given. So we have a 24 right here. And what side is given and what am I looking for? Well, the 24 across from it, that's going to be the opposite side. So I know an O is involved. And the adjacent. There's my adjacent. The hypotenuse is not involved in this one. The hypotenuse, the H, I don't need. So I know I'm dealing with O and A. So I look at the SohCahToa acronym. Aha, O and A. There it is. So O and A tells me to use the tangent. So now when you set these equations up, always start with the sine, cos, or tan. That word goes first. Followed by the angle you're dealing with. So tan of 24 equals the opposite, which in this case is 5, divided by the adjacent, which is x. So again, if you're solving, you're trying to find a missing side or angle eventually, you need an equation to solve. So how do you set up an equation? Right there. It always starts with the word, the angle, and then it equals the ratio, something over something. All right, so now, a little trick you guys will learn in physics. Whenever your variable is on the bottom like this, I like to call it the old switcheroo. You can take the variable to the other side and bring everything that was over there, just kind of switcheroo places with it. You're just cross multiplying, but saving a step. This happens, this situation occurs a lot in physics, so that's how I remember it, the old switcheroo from physics class. So when I'm solving for this x, I can move x to the left-hand side, and the tangent of 24 can go to the right. They just kind of switch places. It's a shortcut. And all right, now's where you need your calculator. So when you put this in your calculator, and we'll talk about being in the right mode in class. You want to be in degrees. We're not dealing with radians in geometry class. So now 5 divided by tangent 24, straight up in my calculator, is 11.2. We're going to round to the nearest tenth in this section. So there you go. So there's the value of x. So let's move along to this one in the middle here. And I'm going to work a little faster. So, but you'll be able to pause the video if you need to. So now here's my 24, my reference angle. So now I'm dealing with adjacent and hypotenuse. Now the opposite is irrelevant because I don't know it, I don't need to know it. So now I can set my equation up. Well, what deals with H and A? So I look back up here, aha, A and H. That's the cosine, the ca. So cos 24 equals adjacent, which is x, over hypotenuse, which is 5. Now this one's a little easier when the variable's in the numerator. You don't have to do the old switcheroo. You just want to solve. You want to solve the equation. You want to isolate x. So how do you isolate x when it's in the numerator? You multiply. Both sides by the denominator. So it crosses out on the right. Straight up in your calculator. 5 cosine 24. So you'll just hit those buttons, and we'll talk about it in class. 5 cos 24. And when you do that, you get 4.6. So x is 4.6. So there's a cosine example. Over here, this last one on the right, this will be a sine example. Opposite, there's the O, and hypotenuse, there's the H. So which one deals with O and H? That's the sine. So setting it up, the word goes first, the angle goes second, opposite is 5, hypotenuse is x. I'm going to need to do the old switcheroo because x is on the bottom. So x equals 5 in my calculator. 5 divided by sine now of 24. So 5 divided by sine 24, x in this case would be 12.3. All right, so there are 3 examples: sine, cosine, tangent examples, and where and what you are dealing with each. All right. So let's move it on. All right, a couple more of the same type of problem here. Trying to find t, I got 44 is my reference angle it's given. So adjacent and hypotenuse. Adjacent, hypotenuse. SohCahToa. Adjacent and hypotenuse, cosine. Cosine, angle, equals t over 22. Variables in the numerator, multiply both sides by the denominator. Straight up in my calculator, 22 times cosine 44, 15.8 equals t. And it should make sense to you. If you get a number bigger than 22, you know you did something wrong. 22 is the hypotenuse, so it has to be the longest side. There's little shortcuts like that we'll talk about in class. Let's go to the next one. 46. Now my reference angle is at the top. Doesn't really matter where it is. Now you're looking at opposite and adjacent. So opposite, adjacent. So that's the tangent. Opposite, adjacent. So the tangent, tan 46 equals t opposite over adjacent 10.5. Again, variables on the top. So just multiply both sides by the denominator. Crosses out over here. In my calculator, 10.5 tan 46. T equals 10.9. Round to the nearest 10. All right, guys. So there are more examples of finding missing side lengths whenever you don't have 30/60/90s or 45/45/90s or Pythagorean theorem is rendered powerless. All right, cool thing about SohCahToa, guess what? We can find missing angles as well. Gasp. Here we go, missing angle scenarios. Look what's happening here. Now the variable is in the angle position. Because there's only one variable that can have it in a right triangle, there's only one angle that can have an opposite side of 6 with an adjacent side of 8. And then we'll talk about some things using GeoGebra this week also, where, you know, it's basically, it just comes off of similar triangles. If I would cut this, you know, in half and make this a 4 and this a 3, it's the same angle, the same ratio. So you can think about it like that as well. All right, so now back to what we're talking about today. And to find this, so now it still goes by the same principle. It still goes by the same principle, which is you're dealing with the opposite and in this case the adjacent. So you still need O and A. So TOA is your OA. So now you set it up, the tangent of x now, you see where the variable is now, equals 6/8. Again, only one angle in a right triangle that can have that relationship of opposite adjacent as 6/8 or 3/4 or 0.75, however you want to think about it. So now when you solve this, it's a little different tactic in your calculator. You're going to use this second feature. It's tan to the -1 in your calculator. And when you do that, a set of parentheses will pop up in your calculator. And you just type it in, second tan of 6 divided by 8. And your variable is 36.9. And again, this is an angle, so you're in degrees. So it should make sense. You should be getting angles, numbers that are, you know, look like angle measures. So like in this case, you can kind of guess what the angle is going to be. That's about right, about a 37-degree angle. Over here, opposite, hypotenuse. So there's O and H, there's the sine. So the sine of x equals 6/10. All right, so now again in our calculators, now you're going to hit second sine. Inverse sine, sine to the -1. 6/10. And then in our calculators, that comes out to be, oh, look at that, it's the same thing. And it better be. I picked the same set of numbers for this triangle. It's a 6, 8, 10. Hopefully you recognize that Pythagorean triple. But it's just with respect to which sides you're given, that tells you which ratio to use. So in the first one, we had opposite adjacent, that's tangent, but we generate the same number as if we're given the 6 and 10 in the second one. All right, so again, this stuff, It's a lot of things to discuss. Your trig teachers have so much fun with you with all the little different relationships that exist in these triangles. All right, so the last couple examples here. All right, we've got trying to find m. All right, so m in this case, I've got an adjacent side and the hypotenuse. So the opposite is not used here. So again, SohCahToa. So adjacent and hypotenuse, that's the cosine. So cosine of m equals adjacent over hypotenuse. When I'm missing the angle, I have to use the second feature. So the inverse cosine, and it pops up the parentheses in your calculator, 4/14 is 73.4 degrees. And the final example today that I'll go over with you, m again. Let's see, now for m, there's opposite and hypotenuse. So opposite hypotenuse is the sine. So sine of m equals opposite 2, hypotenuse 5. So which angle has a sine ratio of 2/5? Let's let our calculator tell us. Inverse sine of 2/5. And the inverse sine of 2/5 is 23.6 degrees. All right, guys, so whoop, there it is. That's trigonometry for a geometry student. Finding missing sides, missing angles, and we're going to go through this in great detail in class, my friends. Thanks for watching.